Hi, my name is Rajesh and welcome back to Science Online. Velocity time graph, in short, VT graph. This is for GCSE Physics students. The velocity time graph is a way of showing the velocity of an object over a period of time. This is in a graph format. Before we go into details, let's talk about velocity. In physics, we deal with two different quantities, vectors and scalars. The vectors, the ones with the magnitude and the direction. Scalars, they only have magnitude, they don't have direction. Say for example, force. The force has a magnitude, 5 Newton, 10 Newton is a quantity. It has a magnitude and it has a direction. The force is always in a given direction. So, force is a vector quantity. On the other hand, say time, temperature, age, these things have magnitude, but they don't have direction. These are scalar quantities. Velocity is a vector quantity because it has a magnitude and a direction. So in our VT graph, when we use the velocity against the time, it's very important you have to keep an eye on the direction as well as magnitude. So in a VT graph, velocity time graph, the direction matters. Let's look at an example. As you can see on the screen, this is a velocity time graph. The time goes in the x-axis because it's an independent variable. The velocity goes on the y-axis, is a dependent variable. If you look at the first section of the graph, the section A, it shows a straight line through the origin and it has a gradient. So it's a straight line, and if you look at the graph, the velocity changes over time and it's a constant change, and therefore it's an acceleration, constant acceleration. So the line with the gradient in a VT graph tells you an acceleration, and if the line is straight, it's a constant acceleration. The next section, section B, is a horizontal line, and you can see the velocity is not changing over time. But you have a velocity, it's not zero. So therefore, the section B is a constant velocity, the object maintaining a constant velocity during the period of time. The next section C, again, is an acceleration. You can see the velocity changes with the time, is constant again. However, if you compare this gradient to the first acceleration, it's a section A, the section C gradient is much more steeper. So this tells you it's a constant gradient but highest acceleration than the section A. So the steepness of the graph can be used to compare the acceleration of the object. Steeper the graph, higher the acceleration. The next part again is a constant velocity. Because it's a horizontal line, velocity is not changing. If you look at the last part of the graph has a gradient, but it's coming down, it's a negative gradient. The velocity changes with the time, so there is an acceleration. However, it's a negative acceleration. So the negative acceleration tells you is deceleration. So the first part is an acceleration, constant velocity, acceleration again, constant velocity, final part is the deceleration. The one other thing you can find out using the velocity time graph is the distance the object traveled. This can be calculated by working out the area under the shape of the graph. In this graph, you probably have to divide the sections into different rectangles, triangles, trapeziums, squares, and work out the individual areas of individual shapes and add them together. The total area under the graph gives you the total distance the object traveled. Okay, let's do a question. As you can see on the screen, a bus travels along a straight road. The graph shows how the velocity of the bus changes during the journey. Now, the velocity time graph shows the pattern of the journey. There are two sections and there's a period, there's no velocity in between those two journeys. The first question is, state the velocity of the bus at 20 seconds. So this is easy because they are only asking the velocity at 20 seconds. So if you go to the graph, at 20 seconds, the velocity of the bus is 12 meters per second. So the answer for the question A is 12 meters per second. If you look at the second question, B, how long is the bus stationary during its journey? As you know, during the stationary period, the velocity of the object is 0. There's only one occasion the bus was stationary in this graph is between 30 and 40 seconds. You can see the y-axis value between 30 and 40 seconds is 0. So the velocity is 0 and therefore the bus was stationary during that time, which is 10 seconds. That's the answer for question B. The question C, calculate the acceleration of the bus during the first 10 seconds. The equation for acceleration is equal to change in velocity over time. So for the first 10 seconds, what is the change in velocity? You can see bus was starting from stationary, 0, to 12 meters per second for the first 10 seconds. So the change in velocity is final velocity minus initial velocity, which is 12 minus 0 over time is 10 seconds, and therefore acceleration for the first 10 seconds is 1.2 meter per second squared. The next question is, what is the total distance traveled during this journey? As we saw before, the total distance traveled by an object can be calculated by working out the area under the shape of the graph. If you look at the graph, you can see there are two trapeziums, trapezium A and B. If you want, you can divide them into triangles and rectangles and find individual areas and add them up. It's fine, it will take a little bit more time, but you can do that. Or you can use the area equation for trapezium and work out the areas of both trapezium and add them together. If you do that, the area of the trapezium A comes up 240 meters squared, and the area of trapezium B is 200 square meters, and the total area is 440, and therefore the total distance traveled by this bus is 440 meters. Now we have seen the velocity time graph and the question. This is one of the topics often comes up in GCSE exam papers, so it's worth spending some time with this. Please try some questions and familiarize it yourself. Hope you find this video useful. Until I see you in another video, bye to you.